Okay, this is the third video in the Bistability series from the UW Synthetic Biology online course. In the last two videos we've discussed bistability, and the last video showed a simulation of bistability, and some of you may be wondering how on earth I managed to find the parameter values that would give me bistability. So I thought I'd just give you a short video on how I did that. So if you recall, this is the model that we had that showed bistability, and these are the parameter values I had that gave us some bistability. So what I'm going to do is I'm going to change these I'm going to change the Hill coefficient so it's probably not bistable. I'm going to run that, gives me that curve, and then I'm going to start up a new tool that allows me to explore the steady states of a system. So if you've got SVW installed, at the top of Jarnac you'll see a menu that says SVW, and the second one down has a general simulation tool. I select that. What happens now is that this model will be transferred to a new tool called the general simulation tool, and what I'm looking for is under the analysis tab there's a thing called rate versus species. If I run that, this shows me, this basically plots V1 and V2 versus the transcription factor P1, and you can see that in this case there's only one intersection point indicating one steady state. So this system isn't bistable. But what I can do is I can try to explore the dynamics of this system by changing the parameter value. So let me move this over slightly to the left. What I want to do is bring up the sliders, and remember that what I had done is I changed the Hill coefficient to 1. So I'm going to change this Hill coefficient. If you watch as I change the Hill coefficient, you'll see the graph change. So you see the graph changing as it becomes more sigmoidal, and there comes a point, well, I need to increase the range. Let me increase the range. There comes a point where first of all I just touch the blue curve, and then finally I get 3 intersection points, and I know that this system is bistable, and I can save this model now and move it back to Jarnac, and it'll be a bistable system. You can see now I've got 3 intersection points, the stable one, the unstable one in between. So this is a very simple tool that allows you to quickly generate bistable systems, and it'll also help you figure out if a particular model can be bistable or not, because you may find that all the changes you make in the parameters will not result in a bistable system. Okay, thank you.